In the year 2025, at precisely 9:18 in the morning, Mars local time, something unexpected drifted across the ochre sky above Jezero crater. NASA's Perseverance rover, a robotic explorer built to search for ancient signs of life, happened to be gazing upward. Its SkyCam, an instrument mounted on the rover's top deck, snapped a frame that would soon ignite global fascination. The image, later uploaded to NASA's official multimedia page, wasn't a blurry amateur shot or the work of an overeager internet theorist. It was genuine, government-issued, and unmistakable. A small object, circled in green by NASA engineers themselves, suspended in the thin Martian atmosphere. Exactly 24 hours later, on October 3rd, 7 spacecraft, belonging to 4 separate space agencies, aligned in a rare moment of cosmic choreography. Together, they captured the most intimate and detailed glimpses ever recorded of the interstellar visitor known as 3I Atlas. Then, suddenly, silence. 4 days of complete quiet. No press briefings, no images, no data, nothing from NASA, nothing from China's National Space Administration, and nothing from the United Arab Emirates. For nearly a week, the agencies that explore our neighboring worlds went dark. Until today, October 7th, when the European Space Agency finally broke the stillness. They released images. What appeared were small, pale smudges against the void. A comet-like body with a faint halo. Its coma faint but present. Unremarkable, almost mundane. It was, at first glance, exactly what one would expect. And yet that very ordinariness is what makes it so unsettling. If ESA's photos were ordinary enough to publish without hesitation, why are NASA, China, and the UAE still silent? Where are the Perseverance frames from October 3rd? Why has China, an agency that releases thousands of Martian photographs every year, rarely missing a chance to showcase its prowess, offered nothing from Tianwen-1? ESA's officials labeled their object a fuzzy dot and said further analysis would take weeks, perhaps months. But what if the other agencies saw something they cannot reveal at all? Because here's what the mathematics tells us. 3I Atlas should not exist on this trajectory. The probabilities are microscopic. 1 in a million, perhaps less. Spectral data suggest the object is venting metals in ways that defy the fundamentals of thermodynamics. Its isotopic ratios indicate an age predating the birth of our solar system, and in just 21 days, it will slip behind the sun, vanishing from every telescope on Earth, at the very moment when solar radiation could either tear it to fragments or, if certain theories hold true, conceal whatever transformation might come next. NASA showed us something on October 2nd. 7 spacecraft observed something on October 3rd. ESA revealed faint dots on October 7th. And the agencies with the clearest optics, the most powerful instruments, the deepest data archives, those remain silent. The question is no longer what 3I Atlas is. The question is what NASA and China witnessed that ESA either could not detect or chose not to say. Now, before the main story continues, a brief interruption, an emergency addendum recorded after the fact. This bonus chapter, breaking news update, was appended only hours after the original narrative was completed, because on October 7th, 25, just as the initial edit wrapped, The European Space Agency released the first verified images and telemetry from the October 3rd Mars flyby. It's breaking news, and it shifts the landscape dramatically. This segment exists to unpack what ESA disclosed, and just as crucially, what they still withhold. Finally, the silence cracks. The wait is, if only partially, over. On October 7th, the European Space Agency did what NASA, China, and the UAE would not. They made their findings public. They offered data, motion frames, and a technical summary of the event that has haunted the scientific community for 4 long days. Yet even this long-awaited disclosure is both illuminating and infuriating. What ESA revealed answers some questions but births many more. And what they have not shown may hold the key to understanding 3I Atlas itself. Here's what their release contained. Using the color and stereo surface imaging system, better known as CAS-SIS, aboard the ExoMars Trace Gas Orbiter, ESA compiled a sequence of exposures captured between October 1st and 7th. When stitched together, those frames form a brief animation, a faint shimmer of motion against a background of fixed stars. There, near the center, drifts 3I Atlas, a slightly out-of-focus white point, descending gradually through the frame. That, according to ESA's official caption, is the comet, a slightly fuzzy white dot. Before disappointment sets in, it's worth remembering what CASIS was built for. Its lenses were calibrated to image the Martian surface, not the darkness beyond it. Every pixel of the animation represents a technical triumph, the stretching of an instrument far beyond its intended design, to capture a traveler from beyond the sun's dominion. The KSS's camera aboard ExoMars was never meant for deep space hunting. It was built to photograph the glowing rust of Mars, the bright, sun-washed plains, and ridges of a planet only a few hundred or a few thousand kilometers below. Its optics were tuned for contrast and clarity, for geological detail. Veins of rock, dunes of ochre sand, subtle color shifts that whisper of ancient water. 3I Atlas, however, was not a few hundred kilometers away. It was 30 million, that is 100 times farther than KSSIS was designed to reach. And unlike Mars, whose surface blazes in sunlight, this interstellar traveler was faint, painfully faint. Nick Thomas, principal investigator for the KCS's instrument, explained that 3I Atlas shines between 10,000 and 100,000 times dimmer than the camera's usual targets. To catch even a trace of it required 5-second exposures. An eternity for this device, whose standard frame is measured in fractions of a second. The images it gathered do not reveal the nucleus itself. At such distance, resolving a rocky core, just a few kilometers wide, would be like trying to spot a mobile phone lying on the moon from Earth. For KSIS, that is physically impossible. What we are seeing instead is the coma, the ghostly cloud of dust and gas expanding around the unseen heart of the comet. ESA's analysis estimates that cloud spans several thousand kilometers, proof that 3I Atlas is alive, exhaling volatile materials as sunlight warms its surface. This behavior is textbook cometary physics. Approach the sun, grow a coma, brighten as heat releases trapped ices. So far, no tail has appeared in the data. Tails form later, when solar wind sweeps gas and dust away from the core, drawing those immense glowing banners that can stretch for millions of kilometers. But tails are fainter than comas, and at this stage, under the limits of Cassis's sensitivity, any such filament would vanish into background noise. ESA scientists note that the tail may soon emerge as the object draws nearer to the sun and activity intensifies. So far, then, nothing exotic, nothing forbidden by physics, just a comet acting like a comet. After weeks of tension and speculation, the story almost feels anticlimactic. Yet within ESA's press release, the language itself hints at the weight of what remains unsaid. Take Mars Express, the agency's veteran orbiter. It too turned its cameras toward 3I Atlas, but in those frames the comet refused to appear. The spacecraft's imaging system could manage only half-second exposures, its maximum safe duration 10 times shorter than those used by ExoMars. The result? A target too dim to register. ESA researchers are now digitally stacking the frames, layering dozens of images atop one another, adding faint signals together so the background noise cancels and real features emerge. It is an old astronomer's trick. If a single photograph shows nothing, take 100 and let mathematics reveal what the eye cannot. Why go to such lengths? If ExoMars already captured the comet clearly enough to verify its coma, why search deeper? Because they are looking for something specific, some signature, some glimmer that could confirm or disprove a hidden hypothesis. That search extends to spectroscopy. During the flyby period, scientists attempted to aim 3 different instruments at the object. Mars Express carries Omega and SkyCam. ExoMars TGO carries Nomad. Unlike cameras, these tools don't capture pictures. They split light into its rainbow of wavelengths, each a fingerprint of atoms and molecules. From those patterns, researchers can infer what an object is made of, whether its glow comes from water ice, carbon dioxide, or rarer metals. But ESA's statement grows evasive here. It does not confirm that any spectra were successfully recorded. Instead, it says that it is uncertain whether the coma and tail were bright enough for spectral characterization. Uncertain. Not yes, not no, just uncertain. And that uncertainty carries enormous weight, because if they did obtain usable spectra, they would already know the composition, whether nickel lines are present, whether carbon dioxide dominates, whether anything defies chemical norms. And if they know, they are choosing silence, opting to say only that it is unclear whether data exist, rather than revealing what those data show. The announcement closes with a cautious schedule. Analysis will continue for weeks and months, not days, extended study, careful calibration, a long dissection of light curves and signal noise before anyone declares what 3I Atlas truly contains. So what, in the end, has ESA really given us? Proof of existence, confirmation of a coma, a set of images entirely consistent with ordinary cometary behavior. They have cracked the silence, but only slightly. Yes, it's there. Yes, it looks like a comet. Beyond that, their words retreat into restraint. Nothing definitive about composition. Nothing about anomalies. If those answers exist, they are sealed for now behind data still under analysis. And that brings us to motive. Why release anything at all while NASA and China remain mute. Perhaps ESA simply has the least dramatic material. Mars Express and ExoMars are fine machines, but their optics and spectrometers cannot rival the precision of NASA's most advanced instruments. NASA's Mars Reconnaissance Orbiter carries the high-resolution imaging science experiment, HiRISE, the sharpest set of eyes ever sent to Mars. In theory, those optics should have delivered images far crisper than anything from ESA's ExoMars or Mars Express. And if those high-rise frames revealed something unexpected, something puzzling enough to demand internal review before release, it would explain NASA's hesitation. While ESA's lower resolution observations could be shared without fear of controversy, NASA's might require careful scrutiny first. There is also the matter of logistics. ESA, unlike NASA, operates outside the influence of United States politics. A government shutdown does not reach its control rooms in Darmstadt. No furloughs, no frozen budgets, no committees waiting for clearance. If ESA's scientists completed their initial checks and decided their data were safe for public release, they could simply act. No bureaucratic gridlock, no waiting for overworked colleagues in another hemisphere. And then there is a third possibility, one that drifts closer to strategy than science. ESA's publication could be deliberate pressure. By going first, by releasing even the modest material they have, they draw a line in the cosmic sand. Here's what we saw. Here's what we're willing to show. Your move. It sets a precedent, builds public expectation, and quietly spotlights the silence from everyone else. Which brings us to the central question. If ESA's imagery shows an ordinary comet with an ordinary coma, no anomalies, no mysteries, why do NASA and China remain silent? Where are the Perseverance SkyCam sequences from October 3rd? Why has Tianwen-1, usually prolific with Mars photography, withheld every frame? Why does the UAE's Hope orbiter, normally eager to share, still hold its data? NASA has already proven that the event was observed, that the cameras worked, that publication is possible. So what precisely is stopping them? During ESA's press briefing, Colin Wilson, the project scientist overseeing both Mars Express and ExoMars, offered a single sentence that now echoes louder than intended. It's always extra exciting to see the orbiters responding to unexpected situations. Unexpected. A small, almost casual adjective, but one that doesn't quite fit. Because nothing about 3I Atlas's approach was unforeseen. Its trajectory was calculated months ago. The timing of its Mars flyby was written into mission schedules. Each spacecraft was positioned deliberately to capture it. So what exactly was unexpected? Not the orbit, not the date, perhaps the behavior, perhaps the way light scattered from the coma, or how its outgassing refused to match the models. Perhaps something invisible in the public imagery appeared in the raw data, an emission line, a magnetic irregularity, a shadow that moved when it should not have. At this point, we are reading tea leaves, parsing word choices, weighing silences. The European Space Agency has given us fuzzy white dots, cautious phrasing, and a promise of more analysis in the coming weeks and months. The great hush has lifted, yes, but only by a crack, just enough to confirm that observations took place, just enough to display a comet behaving as comets do, and paradoxically, just enough to make the muteness of NASA China, and the UAE resound even louder. Whatever their instruments recorded, whatever crossed those sensors on October 3rd remains sealed behind layers of review and internal discussion. ESA's limited disclosure, instead of closing the case, has only deepened the intrigue. If their images were safe to share because they showed nothing unusual, then what did the others see? What data demands weeks or months of guarded analysis before a single frame can be shown? Chapter 1: The 9 Spacecraft That Hold the Truth. Let us begin with what we can state beyond doubt. At exactly 0400 UTC on October 3rd, 2025, the interstellar traveler catalogued as 3A Atlas swept past Mars at a distance of 29 million kilometers. In the language of astronomy, that is close. So close that it offered humanity an observational chance that may not return for a lifetime. For the first time, a visitor from another star system would pass within range of a small armada of functioning probes, 7 spacecraft, operated by 4 different agencies, every one of them awake, aligned, and recording. The first sentinel in this lineup is NASA's Mars Reconnaissance Orbiter, a veteran launched in 2005 and still circling the planet 2 decades later. Its greatest instrument, the High-Resolution Imaging Science Experiment, or HiRISE, was built to pick out rocks no bigger than a dinner plate on the Martian ground. From Mars' orbit, it can distinguish objects 30 centimeters wide. From 29 million kilometers, that sharpness falls to about 30 kilometers per pixel, coarse by planetary standards, yet astonishing when you realize what it means. No telescope in human history has ever captured an interstellar object in such detail. Think back to the others: Oumuamua in 2017 and Borisov in 2019. Fleeting streaks already racing away before our instruments could focus. 3I Atlas is different. We have been tracking it since July, and when the clock struck October 3rd, the alignment was perfect. The second watcher is the European Space Agency's Mars Express, launched in 2003. Its high-resolution stereo camera was designed to sculpt 3-dimensional maps of Martian canyons and volcanoes. But cameras are loyal to light, not to landscapes. Aimed outward, the HRSC can trace the architecture of the comet's coma. The billowing envelope of dust and gas surrounding the nucleus, mapping its contours, its density, its asymmetry, its breadth. The third sentinel is also European, the ExoMars Trace Gas Orbiter, a partnership between ESA and Russia's Roscosmos. It carries 2 scientific jewels: Nomad, nadir, and occultation for Mars discovery, and Cassis, the color and stereo surface imaging system. Nomad is a spectrometer built to sniff trace gases in the Martian atmosphere, but when its lens turns toward a comet, it samples something infinitely older: the frozen chemistry of another star's nursery, material forged billions of years before our sun was born. Fourth in line is NASA's steadfast Mars Odyssey, orbiting since 2001 and still returning thermal data through its THEMIS instrument, the Thermal Emission Imaging System. THEMIS reads heat as sight. Should 3I Atlas exhibit an unexpected warmth, anomalous energy, hidden activity, or hotspots that physics cannot easily explain, THEMIS would catch the glow. The fifth observer sits not in orbit, but on the rust-red ground itself. Perseverance, the rover exploring Jezero crater. Its upward-facing SkyCam had already photographed something unusual on October 2nd, a day before the flyby. But what of October 3rd, the moment of closest approach? Perseverance carries multiple cameras and spectrometers. As the only surface-based witness with a direct line of sight, it might hold the clearest evidence of all. The sixth spacecraft belongs to China. Tianwen-1 has circled Mars since February 21. In 4 years, the China National Space Administration has published over 14,000 images, thousands of views of craters, dunes, and polar caps, each released with pride. Yet when it comes to 3I Atlas, there is nothing. No photographs, no telemetry, not even acknowledgement that the attempt was made. Total radio silence from a program that never misses a chance to showcase achievement. The seventh is the United Arab Emirates HOPE orbiter, also known as the Emirates Mars mission. HOPE carries the Emirates Mars infrared spectrometer, tuned to study Martian weather, but equally capable of analyzing a comet's spectral fingerprint. The UAE has built its reputation on openness, sharing data, collaborating across borders, releasing imagery freely. Yet for this event, their channels are equally quiet. So here we stand, 7 machines that saw the encounter, 1 rover that photographed the approach, and from all of them, only a single official image, that solitary SkyCam frame from October 2nd, with its green circle around a mystery in the Martian sky. But the story continues beyond Mars. Between November 2nd and 25th, the European Space Agency's JUICE mission, the Jupiter Icy Moons Explorer, will aim its instruments toward 3I Atlas as the comet emerges from its closest point to the Sun, its perihelion. By then, the solar furnace will have fully awakened the object, driving torrents of gas and dust outward. If anything extraordinary is going to happen, fragmentation, chemical flare, structural shift, November is when the spectacle will unfold. Yet even this future observation carries frustration. JUICE's current position, deep within the inner solar system and nearly aligned with the Sun, creates a communication blackout. Data gathered in November will not return to Earth until February 2026. 4 months of enforced waiting, 4 months of speculation about what the spacecraft may have seen. And farther out, in the realm of the giant planet, another possibility glimmers. NASA's Juno probe, now studying Jupiter's turbulent atmosphere and magnetic field, could, if granted approval, alter its course for a distant rendezvous. On March 16, 2026, 3I Atlas will sweep within roughly 54 million kilometers of Jupiter. A modest trajectory correction made back in September could place Juno within 25 million kilometers of the object, closer than Mars ever was. That proximity would allow true spectroscopy, high-fidelity imaging, perhaps the first definitive clues about the comet's origins. But NASA has yet to authorize the maneuver. With the government mired in a shutdown, 15,000 agency employees furloughed, and entire departments frozen in procedural limbo, the decision remains suspended. Fuel waits in the tanks. Time leaks away. So, taking stock, 7 spacecraft recorded the October 3rd flyby. 1 rover photographed the sky the day before. 1 probe will observe again in November. Another may in March next year. A network of machines spanning hundreds of millions of kilometers, all of them aimed at a single visitor from beyond the stars. And from this mosaic of effort, this orchestra of data and engineering brilliance, humanity has so far been granted only a whisper. 1 image, 1 circle drawn in green, one question hanging in Martian air. Everything else, the spectra, the thermal maps, the long exposures, the frames stacked in digital silence, remains unseen. For now, the truth lies distributed among 9 spacecraft, each holding a fragment of the story, each orbiting in patient secrecy, while the rest of us stare upward, waiting for someone, anyone, to show us what they found. Chapter 2: The Perseverance SkyCam images, October 2nd, and let us turn to what NASA has actually shown the world. Data, not rumor, imagery, not conjecture. These are not leaks or whispers from anonymous insiders. These are real photographs, stamped, logged, and publicly archived on NASA's official Mars 2020 Raw Images database. They exist in plain sight, available to anyone with an internet connection. The frame in question was captured on Sol 1642. That's the Martian day count since Perseverance first rolled onto the floor of Jezero crater. Sol 1642 corresponds to October 2nd, 2025, by Earth's calendar. The exact time code reads 09-1848 Mars local, mean solar time, mid-morning on the red planet, about 3 hours after sunrise. The instrument that recorded the moment is known as the Perseverance SkyCam, a small, upward-facing camera mounted on the rover's top deck among its cluster of scientific instruments. Unlike the forward-looking navigation cameras or the panoramic mass cam, SkyCam gazes straight toward the heavens. Its role is purely meteorological, to watch dust devils spin across the upper atmosphere, to track drifting clouds, to monitor the faint brightening and dimming of sunlight as seasonal dust storms thicken and fade. But on that morning, it captured something else. In the first frame, a circular halo of the camera's housing is visible, distorted by the wide-angle, almost fisheye lens. Above it, in the upper portion of the image, lies a small but distinct feature. NASA's own image processing team circled it in green. Let that detail linger. This is not an enthusiast's doodle over a JPEG. This annotation appears on NASA's official multimedia page, applied by NASA personnel, drawing attention to something present in the Martian sky. The second frame widens the view, showing more of SkyCam's field. The curved rim of the camera housing arcs across the edges, and there, upper right quadrant, the same object appears again. Faint, yes, but undeniably real. It moved between exposures. It is not a dead pixel, not a cosmic ray hit, not an artifact of compression. It shifted position relative to the camera, which means it was an object with motion, not noise. Technically, this is astonishing. SkyCam is not a high-resolution imager. It was never meant to capture distant celestial targets. Its mandate is near-field monitoring, the sky a few kilometers above the rover, the delicate movements of atmospheric dust. Yet somehow it caught a reflection from deep space. For an object to register at all on that sensor, it must have been bright, bright enough to stand out against the pale salmon light of Martian day. And Mars, though dimmer than Earth beneath its thin air, still glows with scattered sunlight. The image was taken in full morning brightness, not twilight or night. Still, the object is visible. At the time, the distance between Mars and 3Y Atlas measured roughly 30 million kilometers, around 80 times the span between Earth and the Moon. A gulf of black space separates them, Yet Perseverance's skyward-facing camera, designed for weather, managed to intercept the faint shimmer of an interstellar body in motion. Here, however, the timeline sharpens the mystery. October 2nd was not the close approach date. That came 24 hours later, on October 3rd, when 3E Atlas made its nearest pass. On October 2nd, it was still approaching, growing brighter hour by hour. So the question becomes unavoidable. What did Perseverance record the following day? We do not know because NASA has not released those images. Under normal operations, the raw archive updates continuously. New photographs appear within days, often within hours, of acquisition. The rover transmits its data through the orbiters that circle Mars, each acting as a relay. Those packets of information travel through the deep space network, giant radio antennas in California, Spain, and Australia that capture faint whispers from interplanetary distances. From there, the signals flow to the Jet Propulsion Laboratory in Pasadena, are automatically cataloged, and then published to the public site. The process is mostly mechanical. No committee, no curation. Data in, data out. It has worked flawlessly for years. Curiosity's images appear like clockwork. Perseverance's images appear like clockwork. Except not the images from October 3rd, not the ones from the day of closest approach, not the sequence that would show 3I Atlas at its nearest and brightest, the moment that might have given humanity its sharpest view yet of an interstellar visitor passing through our solar system. Those frames are missing. Skeptics might suggest that Perseverance was simply occupied. It is, after all, a working rover. Its primary mission is geological, collecting rock cores, examining sediments, scanning for the ghosts of ancient microbes. Perhaps the science team was focused on another task that day. Perhaps 3Y Atlas was deemed irrelevant to Martian research priorities. But that explanation does not hold. We know from the mission coordination logs that October 3rd was scheduled as a multi-agency observation window. Multiple orbiters, multiple instruments, all directed toward the same celestial target. Perseverance was part of that network, its sensors integrated into the plan. Which brings us back to the silence. The SkyCam's October 2nd image exists, verified, public, and official. The October 3rd data do not. The automation pipeline that normally publishes every rock, every dust devil, every horizon shot, somehow paused for the single day when Mars was perfectly aligned with an interstellar object. The system that never fails did. For now, we have two frames. One faint object, circled in green, another confirming it moved. They are enough to prove that something extraordinary passed above Jezero crater that morning. But until the October 3rd images appear, if they appear, the rest of the story remains sealed inside the servers of Pasadena. What we know is simple, and yet that simplicity makes the silence harder to understand. This was not an incidental event. NASA classified the 3I Atlas encounter as scientifically significant and publicly stated that multiple instruments, including those aboard Perseverance, would observe it. On Sol 1643, corresponding to October 3rd, the rover had every tool it needed. Perseverance can aim its cameras skyward without halting surface operations. It can photograph a rock core and the heavens in the same hour. The SkyCam, perched permanently on the rover's deck, is always watching, always recording the Martian sky. So where are those images? One detail complicates the story. The October 2nd frame, the one we've seen, wasn't trumpeted by NASA. It appeared quietly in the raw image archive, unannounced, surrounded by thousands of routine shots of dust, soil, and sky. No press release, no article, no feature of the week, just another line of metadata. The now famous green circle was added later, almost certainly after someone browsing the archive noticed the anomaly and flagged it. NASA's multimedia editors often add such annotations to highlight interesting formations or cloud patterns. It's normal procedure. But the timing is curious. The annotation appeared, the image spread across social media, and almost immediately, everything went quiet. Remember, Perseverance wasn't alone. Above Jezero crater, the Mars Reconnaissance Orbiter swept overhead. Mars Express and Odyssey were in position. All three carry cameras vastly superior to a rover's SkyCam. By every expectation, they should have captured breathtaking images of 3I Atlas as it approached. Perhaps they did. But if so, none have surfaced. A pattern is emerging, and it is impossible to ignore. On October 2nd, one day before closest approach, a single image appears showing 3I Atlas as a small light in the Martian sky. It's uploaded automatically, as per NASA's established data pipeline. Someone notices it, annotates it, and the world begins to take interest. Then, 24 hours later, the moment of closest approach, the day when 7 spacecraft from 4 nations are aimed at the same object, the pipeline stops. No updates, no raw images, no data drops. From Perseverance, nothing. From the Mars Reconnaissance Orbiter, nothing. From Mars Express Odyssey, Tianwen-1 Hope, nothing. The steady stream of public data appears to have frozen. But data does not simply vanish. It lives somewhere, on hard drives at the Jet Propulsion Laboratory, on secured servers at the European Space Operations Center, within the archives of the China National Space Administration. It exists. We just cannot see it. So why? Why publish the October 2nd image, allow it to be annotated and shared, and then pull down the curtain on everything that followed? There are, broadly speaking, 2 explanations. The first is the mundane one. A tangle of logistics and circumstance. Technical faults, data corruption, communication relays delayed by the Sun-Mars geometry. The U.S. government shutdown disrupting NASA's workforce. 15,000 employees furloughed, many of them the technicians who manage image pipelines. In this version of the story, the pictures are real, harmless, and simply waiting in a queue for someone to process and post them once normal operations resume. Then there is the second possibility, the one that sits uneasily at the back of the mind. The images show something unexpected, something that can't be released without context, something that demands review by multiple agencies before any statement can be made. Because a mere dot of light does not require global coordination. A dot of light does not provoke silence across NASA, ESA, CNSA, and the UAE. Dots of light are routine. They appear, get cataloged, analyzed, published, and forgotten. Yet this time, the flow stopped cold. So what changed in those 24 hours? As 3I Atlas drew nearer, as its coma brightened, and its features came into sharper focus. What new details did the cameras record? What appeared that wasn't supposed to? We can only speculate, but 7 spacecraft know, 4 space agencies know. And somewhere inside climate-controlled facilities on 3 continents, teams of scientists and engineers are staring at images we have not seen, parsing data we are not permitted to read. Whatever appeared over Jezero crater on October 3rd, whatever crossed the eyes of Perseverance, Mars Reconnaissance Orbiter, Mars Express, and their companions remains locked away for now, its truth orbiting just beyond the reach of public light. Chapter 3: 4 Days of Silence. It is October 7th, 2025. 4 days since 3. Atlas skimmed past Mars. 96 hours since 7 spacecraft watched an interstellar visitor at the highest resolution humanity has ever achieved. And for 96 hours, the world's space agencies have met that moment with absolute echoing quiet. To understand why this silence feels so heavy, we need to understand what normal looks like, because this is anything but normal. When Mars missions collect noteworthy data, the release is swift and public. NASA's Mars Reconnaissance Orbiter regularly publishes high-rise images only days after capture. Dust devils twisting across plains, fresh impact craters darkening red sand, avalanches cascading down crater walls, the slow retreat of polar ice. Each image appears online with a caption explaining its science. They are tweeted, featured, celebrated. ESA's Mars Express behaves the same way. When it photographs a mineral deposit, a stormfront, or an unusual landform, the results appear on the agency's site, accompanied by commentary from planetary scientists. Transparency is the rhythm of Mars exploration. And then there is China. The China National Space Administration treats spaceflight as an instrument of national prestige. Every milestone, every orbit, every touchdown is broadcast proudly. When Tianwen-1 arrived at Mars in February 2021, the first images were released within hours. When the Zhurong rover landed that May, color-balanced photographs of the Chinese flag on Martian soil appeared almost immediately. Since Tianwen-1 entered orbit, CNSA has published more than 14,000 images, an average of 12 per day for 4 years. Craters, dunes, rover tracks, sunrise over the horizon, they release everything, because visibility is proof of capability. So when 3I Atlas, the most scientifically significant interstellar body ever to pass our solar system, came within 30 million kilometers of Mars, what did China release? Nothing. Not one frame, not one data set, not even an acknowledgement that Tianwen-1 had turned its cameras toward it. That is not routine behavior. It defies every pattern CNSA has established. If Tianwen-1 had seen an ordinary comet, a coma, a tail, a predictable spectrum, Beijing would have showcased it instantly, likely before NASA or ESA could. They would have declared victory in the race to capture an interstellar object up close. Instead, there is silence. One might point to the US government shutdown as the reason for NASA's muteness, and that explanation covers part of the ground. As of October 1st, more than 15,000 NASA employees were furloughed, 83% of its workforce. The Jet Propulsion Laboratory, which manages most Mars operations, is running on minimal staff. Pipelines that normally hum with automated efficiency now crawl under bureaucratic molasses. But that explanation stops at America's borders. The shutdown does not touch the European Space Agency. It does not freeze China's programs. It does not stall the United Arab Emirates. ESA's funding flows from European member states. CNSA answers directly to Beijing. The UAE's HOPE mission reports to the Emirati government. None of these entities share Washington's paralysis. None have furloughed technicians. None possess any practical reason for delay. And yet, ESA, silent. CNSA silent, the UAE silent. This brings us to the question of coordination, or something that resembles it. In truth, space agencies rarely coordinate beyond the essentials: orbital safety, frequency allocation, collision avoidance. Cooperation between NASA and CNSA in particular is restricted by law. The 2011 Wolf Amendment forbids NASA from using federal funds to collaborate with China without explicit congressional approval. The two programs operate in parallel but separate worlds, competitive rather than hostile. When China lands on the moon's far side, NASA accelerates Artemis. When NASA lands Perseverance, China lands Zhurong. Rivalry is the gravitational law of space politics. So, when both rivals fall silent, simultaneously, about the same event, that is not rivalry. That is synchronicity. And synchronicity suggests coordination. Even ESA, which often partners with NASA but maintains autonomy, has never before withheld data pending American approval. Normally, when Mars Express records something worth sharing, ESA simply publishes it. Yet this time, they wait. NASA waits, China waits, the UAE waits, 4 agencies, 4 continents, 4 governments with entirely different ideologies, united not by cooperation, but by collective quiet. In the language of diplomacy, silence is rarely accidental. In the language of science, it is almost unheard of. When everyone speaks, confusion reigns. When everyone falls silent at once, something extraordinary has happened. When everyone stays quiet, everyone hears the silence. Pause and imagine what it would actually take to make this happen. The emails, the encrypted calls, NASA officials reaching out to ESA counterparts, ESA reaching out to the China National Space Administration, someone looping in the UAE, a chain of quiet messages, culminating in a shared understanding that nothing, absolutely nothing, will be released. But until when? Until all the data are checked? Until everyone agrees on what it means? Until a coordinated narrative can be presented to the public? These are not the kinds of conversations scientists have over a routine comet observation. These are the conversations that begin when something appears in the data that no one expected, and no one wants to be the first to speak aloud. There is a recognizable rhythm to how anomalies are handled in science. When an instrument records something strange, the instinct is not to announce, it is to verify. The immediate reaction is caution. You check the sensors, you compare against calibration data, you make sure a cosmic ray didn't fake a signal. You test for software glitches, compression errors, random noise masquerading as revelation. Then you ask colleagues to review, to reprocess, to see if they can reproduce what you saw. You eliminate every possible mundane cause before daring to consider that what remains might be real. That is good science. That is the discipline that keeps discovery honest. But it rarely requires 4 independent space agencies scattered across 3 continents to all remain silent at once. Unless they all saw the same thing. Unless the anomaly didn't belong to one spacecraft or one sensor, but appeared unmistakably across them all. Unless they are all now checking, cross-verifying, making absolutely certain before anyone risks a single statement. Because once it's said, it cannot be unsaid. And so, here we are. October 7th, 2025. 4 days after the closest approach, the data exist. They live in the servers of the Jet Propulsion Laboratory in Pasadena, in the secured archives of the European Space Operations Center, in the databases of Beijing's CNSA, in the digital vaults of the Mohammed bin Rashid Space Center in Dubai. The files are there. Images, spectra, thermal signatures, telemetry from 7 spacecraft that all stared at 3Y Atlas as it drifted past Mars. None of it has seen daylight, not one frame, not one dataset, not a byte. The only public image remains the humble SkyCam photo from October 2nd. A small, unassuming dot of light above Jezero crater, captured a day before closest approach, a day before the object grew brighter, a day before the resolution sharpened and details emerged. That solitary frame is all we have, our last window before the shutters came down. What changed in those 24 hours? What could be so extraordinary that it made 4 separate space programs, each with different agendas, budgets, and political systems, agree on coordinated silence? The question hangs there, unanswered, stretching across the same black distance where 3I Atlas now moves. The silence continues, and with every passing hour, it grows heavier. No longer an absence of sound, but a presence of intent. A silence that says more than any press release ever could. Chapter 4. What it actually could be. The theories. While we wait for the world's space agencies to finally break their silence, we can only explore the possibilities ourselves. What is 3I Atlas? Because the answer determines whether this is just another cometary visitor, or a moment that rewrites humanity's understanding of its own place in the cosmos. Right now, 4 main theories are circulating through observatories, research forums, and the more speculative corners of the internet. Each carries fragments of evidence. Each contains deep flaws. Together, they frame the mystery and perhaps explain why those who have seen the October 3rd data are guarding it so tightly. Theory 1. The ancient scout ship. This idea, once confined to fringe discussions, has gained surprising mathematical legitimacy. It begins with a radical premise. 3I Atlas is not a natural body at all. It is a probe, an artifact, constructed by an intelligent civilization somewhere in the Milky Way between 7 and 14 billion years ago. To understand the scale of that claim, consider that our sun is only 4.6 billion years old. The Earth, 4 point. Complex life has existed for 600 million years, anatomically modern humans for barely 300,000. By contrast, 3I Atlas, if this theory is correct, was built when the universe was less than half its present age, when the dust that would one day form our solar system still drifted unbound through nebular clouds. Why create such an object? The hypothesis suggests a purpose both humble and vast: observation. A recorder sent to wander the galaxy indefinitely, documenting cosmic events across geological epochs. Not a crewed vessel, Not a ship expecting return, but an autonomous sentinel, perhaps powered by physics beyond our grasp, perhaps dormant for eons, until it encounters something worth noting: a star, a planet, a species. Some versions push further. They imagine 3i Atlas not as a probe, but as an ark, not carrying passengers, but knowledge. The stored essence of a civilization that foresaw its own extinction and refused to vanish entirely. A message in a bottle cast into the galactic ocean billions of years ago, drifting until now, when the tides of gravity finally washed it into our system. Even the timing invites curiosity. If models of its trajectory are right, Thria, Atlas entered the outer edge of our solar system roughly 8,000 years ago, just as humanity began writing its first records, building its first cities, taming rivers in Mesopotamia. If one were designing an observer to monitor a developing intelligence, one might program arrival precisely at such a threshold. Not too early to find only chaos, not too late to miss the moment consciousness awakens. It's an idea that unsettles people, because if it's true, we are not alone, and we have been watched for longer than our species has existed in memory. Theory 2, the active reconnaissance mission. The second theory shares some DNA with the first, but replaces ancient chance with deliberate intent. It proposes that 3i Atlas was launched recently, cosmically speaking, perhaps within the last few million years, by a civilization that detected our sun and wanted a closer look. This interpretation leans heavily on trajectory. 3i Atlas is not tumbling through space on a random hyperbolic path. Its course lies almost perfectly within the ecliptic, the flat plane where all the planets orbit. And along that plane, its route intersects multiple worlds: Mars in October 2025, Jupiter next March. If you were designing a reconnaissance sweep to study a planetary system in a single pass, this is precisely the corridor you'd choose. Another telling feature is its motion. 3e Atlas travels retrograde, moving opposite to the direction of the planets. Far from inefficient, that configuration has a tactical logic. In a retrograde trajectory, the worlds come toward you, maximizing relative velocity and encounter opportunities. If the craft intended to deploy smaller probes or sensor modules, releasing them against the planetary flow would require less energy. The planet's own momentum would carry them into orbit. Nature itself would do half the work. Under this model, 3EI Atlas isn't a relic. It's an active surveyor, a functioning reconnaissance vehicle sent intentionally to inspect us, to map our solar system, perhaps to sample the atmospheres of Mars and Jupiter before moving on into darkness again. Each of these theories, whether the artifact of an extinct civilization or a living emissary, forces a shift in scale that is hard to comprehend. One imagines a story billions of years old, the other, a mission still unfolding in real time. Both would justify silence. Because before any scientist dares to utter artificial, they will test and retest and cross-check 1,000 times over. If even a fraction of this is true, the implications are cosmic and irreversible. Harvard astrophysicist Avi Loeb, one of the most outspoken voices studying 3i Atlas, has offered a restrained but provocative description: a cosmic reconnaissance flyby. Not hostile, not benevolent, simply observational. A civilization, he suggests, could be running a galactic survey, collecting samples, mapping atmospheres, cataloging life-bearing worlds, and we just happen to be one entry on its itinerary. Theory 3. The natural comet with exotic chemistry. This is the default, the position most astronomers still hold. In this view, 3I Atlas is nothing more or less than a comet. A wanderer born in another star system billions of years ago, thrown free by gravitational turbulence and left to drift through the interstellar dark until chance guided it here. There is no intent, no design, just a frozen relic of deep time. Its unusual spectral readings, metal emissions, volatile ratios, odd carbon-oxygen balance can be explained by its birthplace. 3I Atlas likely emerged from the Milky Way's thick disk, a region populated by ancient stars formed in chemical conditions very different from our own. Worlds born there would yield comets with unfamiliar recipes: more carbon dioxide, less water, higher nickel content, stranger ratios of silicates and organics. Odd, yes, but not impossible. Its improbable trajectory? A statistical fluke. The universe deals in vast numbers. In a galaxy of hundreds of billions of stars, each spawning untold comets and ejecting them into interstellar space, one was bound, eventually, to trace a path that looks almost deliberate. This could simply be that one. The virtue of this explanation lies in its restraint. It requires no ancient engineers, no hidden machinery, no extraterrestrial intelligence. Just physics and probability, nature's patient dice roll. Sometimes randomness produces patterns persuasive enough to make us wonder. Theory 4. The hybrid stealth craft. Then comes the most audacious idea. Part science fiction, part engineering blueprint. Suppose an advanced civilization wanted to cross the stars without announcing itself. How would it hide? You wouldn't build something shiny and metallic. You'd take what already exists. You'd choose a natural body, a comet or asteroid, and hollow it out. The ice and rock become armor and camouflage, a shell concealing the technology within. To an outside observer, it behaves exactly as expected. It vents gas. It forms a coma. It even leaves a faint tail. But the outgassing isn't random. It's regulated, engineered to mimic natural behavior so perfectly that no telescope would suspect otherwise. Inside, though, there would be structure, instruments, power sources, a mission. Such a hybrid could explain why 3I Atlas exhibits normal cometary traits while simultaneously producing anomalies, energy readings, spectral lines, or trajectory corrections that ordinary comets shouldn't. It would be both things at once: natural on the surface, technological at its core, the perfect disguise for an interstellar traveler. The idea isn't purely speculative fantasy. Within astrobiology and aerospace design circles, the concept of a camouflaged probe has been seriously discussed. If humans ever attempt interstellar flight, we might adopt the same strategy. Mine an asteroid, use its resources for shielding and stealth, merge technology with geology. It is elegant, efficient, and entirely within the realm of possibility. And if we can conceive it, another civilization could have done it long before us. 4 theories now frame the mystery. The ancient artifact, a relic older than our sun. The active reconnaissance mission, a deliberate visitor conducting a survey. The natural comet, a chemical curiosity of deep space. the hybrid stealth craft, a machine wrapped in stone and ice. Each carries its own logic, each attracts believers. Each leads to radically different conclusions about how humanity should respond. And somewhere, within the secured laboratories, where the October 3rd data are being parsed, inside JPL's servers, ESA's research vaults, CNSA's encrypted archives, scientists are staring at spectra and images and thermal plots, trying to decide which theory the evidence fits. Or perhaps none of them fit. Perhaps what those 7 spacecraft recorded doesn't align with any existing model, forcing the creation of a 5th explanation, or a 6th, something no one imagined needing until the data demanded it. For now, we theorize. We argue, we calculate, we wait. But the people who know, the few who have seen, what Mars Reconnaissance Orbiter, Perseverance TN-1 Hope and the rest observed, are silent, not yet talking, not to us. And that silence, more than any hypothesis, is the loudest evidence that whatever 3I Atlas truly is, it matters enough to be revealed very, very carefully. Chapter 5. The 1,000,000-to-1. Mathematical impossibility. Let's talk about numbers. Not the comfortable kind that fit neatly on spreadsheets, but the uneasy ones that make astronomers lean back from their monitors and wonder if the universe is trying to tell them something. Because the path of 3I Atlas isn't just unusual. It's mathematically absurd. It's important to make a distinction here. The trajectory isn't impossible. It obeys every known law of celestial mechanics. It doesn't violate Newton, Einstein, or Kepler. But the probability of it occurring by chance is so infinitesimal that calling it unlikely is like calling the Pacific Ocean slightly damp. Here's what the numbers say. On October 3rd, 2025, 3I Atlas passed within 29 million kilometers of Mars. On March 16th, 2026, it will graze Jupiter at 54 million kilometers, 2 planetary encounters, 2 of the most scientifically significant worlds after Earth, both in a single pass, both close enough for high-resolution study. Now, why is that statistically extraordinary? First, the plane of its orbit. The ecliptic plane is the flattened disk where all the planets circle the sun. A kind of cosmic record, the planets tracing grooves around the center. Every native asteroid and comet travels roughly along this surface, because all were born from the same rotating cloud of dust 4.5 billion years ago. But 3Y Atlas did not come from here. It arrived from interstellar space, a region without reference to our solar plane. It could have come from any direction, above, below, even perpendicular to the ecliptic. Yet its inclination is 4.89 degrees, nearly flat, almost aligned. For an interstellar visitor, that alignment shouldn't exist. Statistically, only about 0.02%, 2 in 10,000, of all possible approach vectors would land so neatly within the solar disk. Now add the timing. The object doesn't just skim the plane. It passes near Mars and then Jupiter within months, the 2 most heavily instrumented planets after Earth. The chance of that coincidence occurring randomly, roughly 0.2%, 2 in 1,000. Multiply the 2 independent probabilities, and you get 0.04%, 4 in a million, about 1 in 250,000, and we're still not finished. The object's closest approach distances aren't just convenient, they're optimal for observation. Not too close to blur past before instruments can focus, not too far for resolution to fade. Almost as if someone planned the encounter for maximum data yield. Factor in that precision, and the combined odds drop again. Harvard's Avi Loeb has estimated the probability at around 0.05%, 5 in a million, or one chance in 200,000. To grasp what that means, consider this. You would be more likely to shuffle a deck of cards and deal yourself 5 specific cards in a pre-chosen order. You would be more likely to win a lottery jackpot than for 3i Atlas to trace this course by cosmic accident. But then comes the question that keeps mathematicians awake. Why the 5-degree tilt? Why not 0 or 10 or 20? Why this precise angle? There is a hypothesis, elegant and a little unnerving, called the transit survey cone theory. Imagine an alien civilization circling some distant star. They want to find other worlds. They use the same technique we do, the transit method. They watch for tiny drops in a star's brightness as a planet crosses its face. It's how humans have discovered most of our exoplanets. But the geometry of that method is cruelly specific. You can only see transits from one thin slice of space, a narrow cone of angles from which the planet actually passes between its star and your line of sight. Shift a few degrees above or below that plane and the transit vanishes. The planet is still there, but you never see it. Now apply that geometry to Earth. There is a tiny zone in the Milky Way, a wedge of space just a few degrees wide, from which our solar system's planets could be detected via transit. If a civilization were located within that zone, they could identify Earth as a habitable world. They would know we exist. And the plane of that zone, roughly 5 degrees off the ecliptic, exactly where 3i Atlas is traveling. Coincidence, perhaps, but a coincidence with a probability so small that even astronomers, a profession trained to worship randomness, have begun to wonder if something out there was aiming for that angle on purpose. From the right vantage point in the galaxy, our solar system would be an open book. A civilization positioned in that sliver of space could watch Mars, Earth, and Jupiter all drift across the face of our sun. 3 worlds parading in transit. How wide is that vantage cone? It depends on what one hopes to see. If the goal is simply to detect an Earth-sized planet, the cone is razor thin, perhaps only a degree or two. But if you widen your scope to include the asteroid belt, the dense torus of rock and debris between Mars and Jupiter, the geometry changes. The belt itself spans roughly 150 million kilometers in thickness, and from a distant viewpoint, anything transiting the sun within that band would register as a dimming event. The math works out to a cone roughly 10 degrees wide. Any civilization residing within that 10-degree band, 5 degrees above or below the ecliptic, could detect our planets, our asteroids, our sun's subtle rhythm. They would know this system is active, structured, and worth a closer look. And if you were that civilization, how would you send a probe to investigate? You'd aim it straight down the axis of the cone that revealed us in the first place. You'd match your trajectory to the same alignment that made detection possible, 5 degrees. Right down the middle, 3i Atlas's orbital inclination, 489 degrees, essentially 5. Coincidence? Maybe. But a remarkably specific one, so precise that it looks like a line drawn by intent rather than chance. Then there is its mass. Based on brightness and reflectivity estimates, 3I Atlas weighs at least 33 billion tons, perhaps more. For context, the International Space Station weighs about 420 tons. The Space Shuttle, fully loaded, about 2,000. SpaceX's Starship tips the scales at 5,500 tons at launch. 3I Atlas outweighs it by a factor of 6 million. If such an object were artificial, if it had been constructed, the engineering implied would exceed human ability by magnitudes that border on the mythic. We're talking about a civilization capable of moving billions of tons of matter, accelerating it to interstellar velocity, and threading that mass through gravitational corridors with the precision to pass between Mars and Jupiter on a schedule. It would be the technological gulf between a stone axe and a particle collider, between the smoke of our campfires and the machinery of the gods. Avi Loeb refers to this as one of the 7 anomalies of 3I Atlas. The trajectory is anomaly 6, but it is the keystone, the element that holds all others in place. Trajectory determines encounter, encounter determines data, and data determines meaning. If that trajectory is deliberate, if it was targeted, then everything changes. A natural comet with a lucky path is a curiosity. An artificial probe on a planned trajectory is a message. It means someone aimed it. It means someone wanted it here. Of course, mathematics cannot prove intention. One chance in 200,000 is improbable, but not impossible. Lotteries are won. Lightning strikes twice. The universe occasionally rolls a perfect throw. But from the perspective of an agency scientist, someone sitting in Pasadena or Darmstadt staring at telemetry that should not exist, the odds are enough to pause a data release. If you were that scientist, what would you do? You'd ask hard questions. Is the trajectory natural, or is it trying to tell us something? Did someone mean for us to see this? Was it designed to spark precisely this reaction, to make us notice, to make us wonder? Because the math doesn't lie. The orbit is what it is. The probability is what it is. 1 in 200,000. The meaning behind those numbers, that's the part keeping astronomers awake tonight. Somewhere, buried in the unreleased October 3rd data, in the high-resolution images, in the spectral fingerprints, in the heat maps we've not been allowed to see, there might be the answer. And if the odds truly point toward intent, then every kilometer of 3I Atlas's path across our sky is not just a trajectory, it's a sentence written in mathematics. A message we have only just begun to read. Chapter 6. October 29th, the hidden moment of truth. There's a date quietly circled on calendars in observatories across the planet. October 29th, 2025. 22 days from now. 3 Shoy. Atlas will reach Perihio Mebahelion, its closest approach to the Sun. 1.36 astronomical units, roughly 203 million kilometers, just inside the orbit of Mars, just outside the orbit of Earth. And this is the moment everyone has been waiting for. The moment when the object, whatever it truly is, will be tested by fire. But it is also the moment when we will see nothing. The geometry is merciless. From Earth's perspective, 3I Atlas is diving toward the Sun, slipping behind it, then, if it survives, emerging again in late November. During those crucial hours of perihelion, when solar radiation is at its most violent and a comet's behavior most revealing, our view will be completely blocked. The sun itself will stand in the way. This isn't merely inconvenient, it's catastrophic for observation. Because perihelion is when comets show their truth. Far from the sun, they are silent, cold, inert, featureless. The volatile ices remain locked in shadow, the surface black and still. But as they fall inward, sunlight awakens them. The frozen crust begins to sublime, ice transforming directly into gas, erupting in jets of vapor and dust. A coma blooms. A tail stretches for millions of kilometers. The nucleus begins to spin, crack, vent. The comet, in a very literal sense, comes alive. At perihelion, that process peaks. Temperatures soar high enough to vaporize minerals that had remained solid for eons. Complex organics fracture. Subsurface ice bursts outward through new fissures. Some nuclei fragment entirely, torn apart by thermal stress and tidal forces. For 3I Atlas, the energy influx is staggering. Roughly 12 gigawatts of solar power striking its surface, equivalent to a dozen nuclear plants running at full capacity, concentrated on a body only a few kilometers wide. If it's a natural comet, we should expect the usual spectacle: an explosive surge of outgassing, a brightening coma, a radiant tail, maybe even disintegration. But if it isn't, if 3I Atlas is something else, perihelion could reveal a very different kind of transformation. There's a maneuver in astrodynamics known as the Oberth effect. When a spacecraft fires its engines at the deepest point in a gravitational well, every bit of thrust multiplies. Close to the sun, a tiny burn can translate into an enormous orbital change. This is how interplanetary probes slingshot to outer worlds, and it's how, hypothetically, an interstellar craft could alter course while hiding behind the sun. If 3I Atlas wanted to decelerate, wanted to drop from a hyperbolic escape path into a stable solar orbit, this would be the moment. Hidden from Earth-based telescopes, masked by solar radiation, a reverse Oberth burn could transform its trajectory completely. Instead of sailing outward forever, it would stay. Harvard's Avi Loeb notes that the timing is almost too perfect. Behind the sun, at maximum heating, in a region where any propulsion signature would be drowned in noise. If one wished to hide a course correction, this is where you would do it. And if 3I Atlas were not just a single object but a carrier, if it held smaller probes within, then perihelion would be the ideal deployment point. Because the comet's retrograde motion means it moves opposite to the planets. A probe released here could intercept Earth's orbit effortlessly. The planet would, in effect, run into it. A perfect Trojan horse, a harmless-looking comet that, at its brightest and most unobservable moment, does something we cannot see. Do scientists believe this? Most will tell you no. Most expect the familiar script: a brightening, a tail, maybe fragmentation, and a faint speck returning in late November, exactly as physics predicts. But the gap in our observation bothers people. It bothers them enough that multiple observatories have scheduled all-night watches for the re-emergence. It bothers them enough that ESA, NASA, CNSA, and the UAE have quietly coordinated instruments to be ready the instant the object reappears. Because the uncomfortable truth is this: the moment when 3I Atlas will most likely reveal its nature, its composition, its structure, its purpose, is the very moment we cannot see. A window of silence, carved into the sky by geometry itself. And whatever happens behind the sun on October 29th may decide whether 3I Atlas leaves us or stays. If 3I Atlas vanishes behind the sun as one thing and reappears as another, we'll have missed the transformation entirely. We'll possess a before and an after, but nothing in between. The middle act erased by the blinding light of the sun. We'll know that something changed, but not how or why or what precisely occurred during those hidden hours. There's a philosophical echo here. The old thought experiment about a tree falling in a forest with no one around to hear it. But this isn't quite that. If an interstellar object alters its nature at perihelion and no one observes it, it still happens, and the evidence will follow. We'll know by what comes next. If 3A Atlas reemerges in late November on a new trajectory, or shining with altered brightness, or trailed by smaller companions that weren't there before, we'll know that something took place. We just won't have the language to describe it yet. The missing October 3rd data, the images still withheld, might be the prologue to this mystery. If those images captured something unexpected, something inconsistent with a standard comet's behavior, then perihelion becomes not just a scientific milestone, but a moment of reckoning. It becomes the point at which we either confirm that 3I Atlas is merely an extraordinary natural object, or confront the possibility that it is something else entirely. 22 days, 3 weeks and a day. That's how long until the hidden moment arrives, until 3I Atlas slips behind the sun and the instruments of Earth fall blind, until we enter that liminal space between knowledge and speculation, forced to wait and wonder what happens on the other side of the light. We hope that when it returns, it will still be just a comet, following its path back into interstellar darkness. We hope it hasn't changed course. We hope it hasn't decided to stay. We hope whatever those 7 spacecraft saw on October 3rd was strange but explainable. But hope is not data. Hope is what remains when observation ends. Hope is what scientists reach for when the instruments fall silent. And right now, as the agencies remain quiet and the countdown to perihelion continues, hope is all we have. That, and the certainty that when 3I Atlas reemerges in late November, we will finally learn whether that hope was justified. Chapter 7. The nickel without iron smoking of all the mysteries orbiting. 3. Atlas, one anomaly stands apart from the rest. One that refuses to fit inside the tidy margins of natural explanation. One that, once you understand the chemistry behind it, makes you stop and question whether this object is obeying the same rules as everything else in the cosmos. It's the nickel, or more precisely, the nickel without iron. Let's start with some stellar basics. When massive stars die, they do so violently. Their cores collapse, their outer layers detonate in supernovae, and in those last incandescent moments, heavy elements are born. Carbon, oxygen, silicon, and metals like nickel and iron are forged together in the crucible of the dying star's heart. They are siblings born from the same nuclear reactions, formed in the same layers, bound by the same physics. Wherever nature scatters nickel, it scatters iron too. Their ratio may shift from one world to another, but never has the universe shown us one without the other. Finding nickel without iron is like finding thunder without lightning. Until now. In July and August of 2025, the Very Large Telescope in Chile turned its spectrometers toward 3I Atlas. Spectroscopy is the astronomer's alchemy, breaking light into its wavelengths, reading the lines where elements leave their fingerprints. When the data came in, it was unambiguous. 22 distinct emission lines for neutral nickel atoms in the coma. The gaseous halo around the object, 22. Not a whisper, not a suggestion, but a chorus. And iron? Nothing. Not a single detectable line. The instruments were more than sensitive enough. They've recorded iron in countless other comets. But here, silence. To grasp how strange that is, you have to understand temperature. Nickel's melting point is 1,055 degrees Celsius. Its boiling point is 2,913 degrees. At 3 astronomical units from the Sun, roughly 450 million kilometers, the surface of a comet should be barely warm, perhaps 100 degrees Celsius at most. Nowhere near the infernal heat required to vaporize metal. So how is 3I Atlas producing nickel gas? There is one known mechanism. Nickel can hitch a ride on volatile compounds, carbonyl molecules, that evaporate at far lower temperatures. As these compounds break apart in sunlight, they release nickel atoms into space. This pathway, called the nickel carbonyl channel, explains metal vapor in some comets. The catch is that iron behaves almost identically. It forms similar carbonyls, breaks down under similar conditions, and releases its atoms in the same way. So, if this process is at work, both metals should appear in tandem, as they always do. But here, only nickel sings. That leaves two options, neither comforting. Either 3. I Atlas contains almost no iron, an unprecedented composition for any natural body, or the ratio between nickel and iron is so extreme that iron is effectively invisible. And then the data took a stranger turn. Between July and August, as the object drifted from 3.88 to 2.85 astronomical units, the nickel emission didn't just rise, it exploded, increasing 25-fold in a single month. By late August, the production rate was described in professional literature as extreme, the highest ever measured for any comet at that distance from the Sun. The closer 3I Atlas came, the more ferociously it vented nickel, as if something internal were turning up the output deliberately. Now consider this. On Earth, when we want nickel without iron, we use an industrial method called the Mond process. Nickel ore is exposed to carbon monoxide at carefully controlled temperatures, forming nickel carbonyl gas. The gas is separated from impurities, then decomposed at higher heat to produce pure nickel metal. It's used anywhere high purity nickel is required, from aerospace alloys to electronics, and it produces a chemical signature indistinguishable from what 3I Atlas is displaying. Strong nickel emissions, no iron counterpart. No one is claiming proof of artifice. But the match is unsettling. What we're seeing from this interstellar object aligns more closely with an engineered purification process than with any natural geochemical or thermal mechanism. It's as though, out there in the cold beyond Mars, something is refining itself. The spectrum of 3I Atlas doesn't look like a comet's at all. It looks like the exhaust plume of a nickel refinery drifting through the void. Could there be some exotic chemistry that mimics this pattern? Possibly. Maybe. Perhaps 3I Atlas formed in an alien cradle, around an ancient star where conditions skewed metal ratios in ways we've never witnessed. Maybe the nickel carbonyl channel behaves differently under interstellar conditions, more selective than we realize. Maybe magnetic fields or electric discharges somehow strip out iron while leaving nickel untouched. But here's the problem with maybe. We've observed hundreds of comets, icy bodies from our own solar system, dusty wanderers from the Kuiper Belt and Oort cloud, and now 3 confirmed interstellar visitors. And not one, not a single one, has ever shown this signature, nickel without iron. If this is merely chemistry, if this is simply nature being eccentric, why has it never happened before? Why is 3I Atlas the exception to every rule the cosmos has shown us so far? The scientific paper that reported the VLT data is cautious, as scientific papers must be. It calls the findings extremely puzzling. It acknowledges that detecting any metal emissions in such a cold cometary environment is already unexpected. It describes 3I Atlas's nickel production rates as extreme, and its abundance ratios as unprecedented. And then it stops, precisely where the reader's mind refuses to. Because what those data describe does not look natural. It looks deliberate. Avi Loeb has said what the paper wouldn't. He's noted that the spectral profile of 3I Atlas, the distinct nickel lines without corresponding iron, is characteristic of industrially produced alloys refined through the carbonyl chemical process. In other words, the same chemistry used in Earth's metallurgical plants. He argues that while a natural explanation might exist, the burden of proof has flipped. It's no longer about proving it's artificial. It's about showing how it couldn't be. Because right now, the simplest explanation consistent with the data is that we are seeing artificial nickel production. And this brings us back to the silence. Because if you're a space agency, if your orbiters around Mars captured high-resolution spectra during the October 3rd flyby, you already know the answer. You've analyzed the coma from much closer range than the VLT ever could. You've seen the emission lines with higher sensitivity, greater resolution, deeper precision. So what did those spectra show? More nickel? Still no iron? Did the ratio widen? Did new elements appear? Did the pattern start looking even more engineered? We don't know, because the data are locked away. The VLT results are public because the telescope belongs to an international consortium with open access policies. But spacecraft data are another story. Those channels are hierarchical, bureaucratic, easily frozen. They can be paused, reviewed, classified. The nickel signature is, so far, the closest thing to a smoking gun. Not proof, but evidence with edges sharp enough to cut through denial. If confirmed by orbital spectrometers, it would force the question no one wants to ask out loud. And those closer observations, the ones from October 3rd, will either confirm the pattern or collapse it. They might show that iron finally appears, that everything normalizes, that this was just chemistry playing a trick. Or they might show that the ratios grow even stranger, that the industrial resemblance becomes undeniable. Either way, those spectra exist. They're sitting in servers at JPL, at ESA, at CNSA, waiting to tell us whether the light of an interstellar visitor is whispering the impossible truth that somewhere out there, someone built something and sent it here. Chapter 8: The Seven Anomalies. Connecting all the dots. We've spent time dissecting each clue, the trajectory, the nickel, the silence. But the true weight of 3I, Atlas, doesn't lie in any single piece. It lies in how all the pieces lock together. Because this object doesn't have one anomaly. It has 7. And when you stack them side by side, their cumulative improbability begins to look less like coincidence and more like design. Anomaly 2: the forward jet. When the Hubble Space Telescope captured 3I Atlas on July 21st, 2025, astronomers noticed something that made them pause. A bright, narrow jet of reflected sunlight extended ahead of the object, toward the sun, not away from it. Normally, a comet's tail trails behind, pushed outward by solar radiation and wind. But 3I Atlas showed a forward jet first, a 10-to-1 column of light projecting in the wrong direction. For Wakes, there was no conventional tail at all. Only by late August did a faint, ordinary-looking tail finally appear. That early behavior, an intense collimated plume aimed sunward, resembled a nozzle more than a natural vent. Unprecedented? No. Impossible? No. But distinctly atypical and disturbingly mechanical in its precision. Anomaly 4: carbon dioxide dominance. In August, NASA's James Webb Space Telescope and the Sphere-X Observatory analyzed the spectrum of 3I Atlas's coma. What they found defied expectation. 95% carbon dioxide, 5% water, a ratio of 8-to-1. Most comets in our solar system are water dominant, often 2 parts water to 1 part carbon dioxide. An 8-to-1 reversal is staggering. A carbon dioxide-rich comet would wake up earlier, its dry ice surface sublimating long before water, ice ever warms. And indeed, 3I Atlas became active at 4.4 astronomical units, much farther out than ordinary comets begin venting. Perhaps it formed in a colder, older protoplanetary disk, where carbon dioxide condensed abundantly. Or perhaps this chemistry isn't natural at all. Because carbon dioxide isn't just volatile, it's propellant. It's stable, easy to store, and perfect for cold gas thrusters. A spacecraft using it for fine trajectory control would look exactly like a carbon dioxide-rich comet. Its outgassing would be thrust. Its jets would be guidance. Propellant disguised as natural volatility. A coincidence? Or an intentional mimicry of comet behavior? The composition alone can't decide that, but paired with the trajectory and the nickel signature, it begins to whisper a pattern. Anomaly 5: the extreme negative polarization. To grasp this one, you have to think like light. When sunlight bounces off a surface, the reflected waves align in specific directions, what physicists call polarization. The degree and type of polarization reveal the texture, composition, and geometry of whatever the light touched. Most comets show mild negative polarization, a subtle signature caused by the scattering of light through fine dust grains. But 3i Atlas didn't just show it, it amplified it. The readings were far outside the normal range, deep into territory rarely seen in nature. Such extreme negative polarization implies that the particles in the coma, those microscopic fragments surrounding the object, are unlike typical cometary dust. Their shapes, their mineralogy, even their internal structure differ radically from what's expected. Some scientists have suggested exotic mineral origins born in ancient chemically distinct star systems. Others have noted that certain engineered materials, polished composites, nanostructured alloys, metallic foams, can produce precisely this level of negative polarization. In other words, it could be the reflection of something manufactured. When viewed separately, each anomaly might be dismissed. A strange jet, an odd composition, an extreme scattering effect. But taken together, they begin to draw a single outline, an object that behaves like a comet only when we expect it to, and does something else entirely when we're not looking. Anomaly 7. The WOW signal AW alignment. It's not conclusive either way, but it's another property that doesn't quite fit the comet template. On August 15, 1977, the Big Ear radio telescope at Ohio State University picked up a powerful, narrowband transmission at 1,124 MHz, the exact frequency of hydrogen, the universal calling card of radio astronomy. The burst lasted 72 seconds, long enough to be tracked across the sky, and was so distinct that astronomer Jerry Eman circled the data and scrawled a single word beside it. Wow. The signal never repeated. It never reappeared. It never found an explanation. Its coordinates, right ascension, 19 hours, 25 minutes, declination, 27 degrees, pointed roughly toward Sagittarius, in the direction of the galactic center, a region dense with ancient stars and tangled radio noise. Now comes the uncomfortable coincidence. Trace 3. Atlas backward through time, reconstruct its path through interstellar space. And in 1907 it was roughly 600 astronomical units from Earth. Still in the outer darkness, but close enough for a directed transmission to register. Its position in the sky then lay only 9 degrees in right ascension and 8 degrees in declination from the WOW signal's origin. 9 degrees out of the full 360 of the celestial sphere. The odds of that alignment happening by random chance? About 0.6%. 6 in 1,000. Could 3i Atlas have been the source? If so, the power requirement would fall somewhere between 0.5 gigawatt and 2 gigawatts, the output of a terrestrial nuclear reactor. Immense but not unimaginable. The WOW signal was also blue shifted, meaning the emitter was approaching Earth, a detail that happens to match 3i Atlas's inbound trajectory. That has led some theorists to wonder, what if the WOW signal wasn't a call, but a scan? A radar sweep probing the neighborhood for planets, a survey beam that happened to brush across our solar system for 72 seconds before moving on. If so, the implications are staggering. In 1977, the object might have detected the faint dips of our planets crossing the sun, realized one of them occupied a habitable zone, and subtly altered course. 48 years later, right on schedule, it arrives, or it's all coincidence. 6 in 1,000, not impossible, just improbable. Another data point that can be read either way. Here's what all 7 anomalies tell us when taken together. Individually, Every one of them has a natural workaround. The size might be a statistical fluke. The forward jet, an odd, outgassing geometry. The nickel signature, exotic chemistry. The carbon dioxide dominance, a strange birthplace. The polarization, unusual dust. The trajectory, improbable but random. The wow signal alignment, pure happenstance. Each explanation can stand on its own, but only barely. Stack them and the probability space collapses. The natural model begins to require too many exceptions, too many one-in-a-million allowances, all converging on a single interstellar object. Avi Loeb has even quantified it on what he calls the Loeb scale, a rough gauge from 0, definitely natural, to 10, definitely artificial and possibly active. He places 3I Atlas between 2 and 4. Not mundane, not conclusive, squarely in the ambiguous middle, the region that demands new data before judgment. And that's exactly where we remain, suspended in the gap between certainty and speculation, waiting for the locked-away results from October 3rd. Somewhere, behind institutional firewalls and unspoken agreements, the answers exist. The images, the spectra, the heat signatures, the truth of whether those 7 anomalies evaporate under closer inspection or harden into evidence of intent. They know what 3I Atlas really is. We're just waiting for them to decide when or whether to tell us.